geospatial data. Please welcome Rio.
Thank you very much. Hello everyone, thank you for joining my talk. My name is Rio from the ArkEdge Space. I'm excited to share how we leverage microsatellite, IoT technologies, and FOSS4G tools to deliver geospatial applications around the world. Let me start with briefly introduction of ArkEdge Space. We are a satellite startup based in Tokyo, Japan, founded in 2018. Our core business is covered the design, development, operation of microsatellite, which enable cost-effective and rapid access to space capabilities. We build satellite constellation for various missions, such as communications, Earth observations, PNT, and more. In addition, we provide education, consulting, and satellite data utilization service related to the satellite engineering, helping expand ecosystem around the space technologies. Let me brief introduction explain what satellites are. So today I bring our satellite mock-up. So this is a real-size satellite. So we create this kind of very small microsatellite. So microsatellite is very extremely small compared to the original one, less than 1/100th size. Yet they can still carry powerful instruments such as communication tool or high-resolution camera. Their advantages include being far more cost-effective, much more faster to develop and launch, and provide frequent revisit coverage, which is increasingly important for our current monitoring. And this slide shows the range of satellites that ArkEdge Space developed, from very small microsatellite to 100-kilogram class satellite. These satellites supported a wide variety of missions: technology demonstrations, Earth observation, communication, monitoring, and even deep space explorations. Our flexible design and manufacturing capability allow us to adapt satellites to many different needs. Here is one example of satellite we have already launched, OnlineSat, developed jointly with Taiwan space agencies. Although the image it acquires is monochromatic, but it achieves the highest resolution among the microsatellites in the world. We have already launched the satellite equipped with a hyperspectral camera. Although the spatial resolution is worse, but hyperspectral data enable advanced observation and analysis thanks to its rich spectral information useful in agriculture, environmental monitoring, and many other fields. Furthermore, almost all our satellites are equipped with IoT receivers to make it possible to send and receive short messages from regions that have no cellular network. Thanks to this capability, we can collect meteorological data, soil moisture data, river water level, and many other ground measurements from anywhere in the world. This combination of satellite data and IoT data is one of our unique strengths. So today I bring my IoT ground station terminal. So you can plug any type of sensor in this terminal. You can send the data directly to our satellite. So, in addition, we have launched a satellite dedicated to many maritime monitoring or maritime communication that have been conducting technology demonstration. In addition to this, we developed a geospatial information platform called ArkEdge Insight. This platform integrates satellite data as well as drone imagery, satellite data, IoT sensor data, weather information, and government-owned statistical dataset, enabling agile development of applications across many fields. By using FOSS4G tool, we are able to build a user-friendly, open, and scalable platform accessible even to people who may not have deep expertise in the GIS. Here is some example what the ArkEdge Insight can do. Its applications span many domains, from agriculture, rainwater management, glacier monitoring, flood analysis, and maritime monitoring, GHG monitoring, and so on. And we have a track record We have a strong track record of collaborating with government, agencies, embassies, research institutions around the world. Our goal is to deliver practical, local relevant solutions, especially in global south countries. By establishing partnership with a public and private organization, we aim to contributing to solving social and environmental issues through geospatial intelligence. Let me introduce a few examples of our international expansions. In Paraguay, we have already released an agricultural application that supports government workflow, such as soybean seeds permission and crop monitoring. We are developing a flood forecasting application combining satellite rainfall data and IoT water level gauge sensors. We are also expanding the transition of hazard map into the WebGIS application. In Brazil, that is the right corner one, we are piloting an application that detects the offshore oil spill in satellite imagery and cross-check them with special AIS data. In Kyrgyzstan, we are running a pilot project integrating satellite data and IoT data for glacier monitoring and GHG monitoring. In other countries, we are planning many types of the POC project. So now let's look at some key points we face when developing applications internationally. In many global south countries, financial resources are limited. So applications need to be low cost and sustainable. A solution must remain usable after external support or development project end. There are also challenges with the satellite and other geospatial information itself. Data license restriction may prevent secondary use or limit who can access the data, resulting in poor data reach or limited practical use. Large data size and complex format is also many required expensive and complex GIS software or specialized expertise, making them difficult for local users to handle. Moreover, satellite data that is being collected from far away from the ground inherently has limitation in accuracy, spatial resolution, temporary frequency. That factor guides us to how we design our solutions. To address this challenge, we follow three key approaches. First, we focus on the web-based intuitive application that anyone can use without specialized expertise. Second, we rely on open and free geospatial data and FOSS4G technologies to keep development agile and maintenance sustainable. Third, we integrate additional local geospatial information, such as government dataset, partner-owned data, ground truth IoT data collected via our ArkEdge IoT network. Here is our application development journey. Since 2021, ArkEdge Space has been focused on the mass producing variety type of the microsatellite. As a next step toward expanding the use of satellite data and contributing a global scale problem solving, we launched a new division in January 2024 dedicated to developing applications that deliver value directly to the end user. Starting around March 2024, we began developing a geospatial application. Although the initiative is still young, but we have already launched a pilot project in multiple countries, all within less than 2 years, powered by FOSS4G. From here, I would like to explain in detail how we actively leverage FOSS4G to enable agile application development and the technical choice behind that approach. In the early phase of application development, our goal was to stay very close to the user feedback. That is why we want to rapid prototype type mockup test them immediately, and keep repeating this cycle of tries and errors. To make this possible, our core approach was very simple. Minimize the backend as much as possible, and focus on the fast, flexible front-end development. Here is technologies we use in this phase. First, we built a single-page application hosted on GitHub pages, making development fast, infrastructure-free, and easy to access control. Second, we use PM tiles delivered from Amazon S3 and CloudFront. PM tiles work extremely well for distributing large satellite data and other geospatial data, not only raster tile data, but also vector tile data. For mockup application, we mainly deliver pre-processed static data stored in S3 and distributed through CloudFront. Third, we used proto-map base map at first, and later we switched to Amazon Location Service to support global deployment. This combination allows us to develop prototype quickly and iterate with users. In the next phase, we need more realistic and polished user experience. This means adding interactive feature, automatic data update, and dynamic processing. To achieve this, we built a satellite data delivery pipeline using T-Tiler to process and deliver cloud-optimized geotiff satellite data dynamically based on user interaction. We place processing server near the source of satellite data, for example, in the AWS US West region close to the Sentinel-2 data hub, and delivery only ready to use results to user worldwide. We also incorporate with modern machine learning model, such as a meta segmentation descent model, enhancing user interaction and analysis. Finally, we optimize our system to perform on-the-fly processing, both satellite data and machine learning inference, removing the need for heavy processing. This is not keep the backend very simple, but also enable low-cost global development because pre-processing satellite data for the entire planet is infeasible. Before moving on, let me summarize where we are so far. After this point, I have explained how we have been used for FOSS4G tool to develop our application in the Agile and iterative way. From the next section, I would like to introduce the initiative we are currently working on, effort aimed to make our application even more robust, scalable, and variable for the real-world use. A key point of our expansion is ground data collection using our IoT satellite constellations. Satellite data alone has limited in resolution or time frequency. By integrating IoT ground truth data and local dataset, we can create more reliable solutions. Because almost all of our satellites have IoT communication capabilities, we can collect data even where there is no internet or there is no cellular coverage. On the long-term goal for us to build a low-cost open satellite IoT network with more 50 satellites planned in coming years. Another major initiative is open source and ecosystem building. ArkEdge Space is not expert in every field. So instead of trying to do everything ourselves, we provide tools or source code that make satellite data easily to use for domain expert. This allows, for example, agricultural experts, environmental researchers, and other professionals to work directly with satellite or IoT data. By doing so, we can build much deeper collaboration, and these tools also contribute to capacity building and local skill development, especially in global South countries. Giving partners access to our tool and source code allow local teams can operate and maintain and even improve their applications themselves, supporting long-term sustainability and empowering local communities. We are also opening our platform to web and IoT companies. Traditionally, satellite data have been difficult for ordinary developers to work with. But by sharing our platform, tools, know-how, we make satellite data accessible to general web engineers. This greatly expands the potential for innovation and enable new real-world applications across many use cases. Before closing this presentation, I would like to share a bit of philosophy behind our works. We think technology alone is not enough. Understanding real user needs is very, very essential. Although we develop satellite and geospatial application, but we are not building everything from inside an office. When working only with satellite and software, our thinking tends to become too global and detached from real-world conditions. To avoid this, we believe it is essential to walk the field ourselves, observe, listen, feel, and stay grounded on the ground realities throughout satellite development and geospatial application design. This is why we actively visit a project site, talk with local communities, collect data together, and design solutions side by side. This field-driven collaborative approach ensures that our application meet real needs and create real impact. Finally, I would like to share an important message. We truly need your collaborations. We hope to bring our platform, geospatial platform and application to many more regions. And we would like to work together with all of you to make this possible. To fully unlock the power of satellite data, your support in collecting valuable local data sets such as weather data, water level data, or soil moisture, air quality data, or many other data is essential. We also hope to co-develop applications with domain experts in agriculture, disaster monitoring, environmental, hydrology, and so on. And of course, we are looking forward to growing the FOSS4G community together with all of you. This is why collaboration with experts like you is so important for creating meaningful and impactful applications. Here is a summary. ArkEdge Space developed microsatellite, operating a satellite IoT network, and building a geospatial application, especially in the global south countries. Using FOSS4G and open geospatial data, we rapidly build user-centered application and develop them sustainably. We have active projects in agriculture, water management, disaster monitoring, environmental monitoring, and more, integrating satellite data and IoT ground data and local datasets. Going forward, we will continue delivering geospatial intelligence to the world, collaborating with partners, and contributing to the FOSS4G communities. If you are interested, please come visit our sponsor booth. Thank you very much.
Thank you very much, Rio. Do we have any questions? Yeah. Might see if you can project from where you are, if that's okay.
Have you flown anything over New Zealand of interest? And what sort of resolution data?
Thank you very much. So actually, we don't have project in New Zealand. So our satellite is very, very small. So how can I say, spec is not good rather than big satellite. So our resolution, resolution of our camera is not so good. For example, the panchromatic camera for 2.5 GSD and the hyperspectral camera is for 30-meter resolution. So I think it is how can I say, not for great benefit for urban monitoring. But of course, we want to utilize the drone data or airborne data or other GIS data. So we want to, of course, we want to collaborate your project.
I was just wondering if you could talk a little bit about the sort of accuracy, like horizontal accuracy of the microsatellites that you deploy.
Horizontal accuracy means when capture the imagery of ground.
Yeah.
It is how can I say, maybe several kilometers. We targeting the some point, maybe it shifts several kilometers. But how can I say, after post-processing, it is easy to match the image to the geolocation. But for example, the forest monitoring or maritime monitoring, it is difficult to match because there is no landmark.
And do you provide those post-processed data as well to your users, or is that something that users will do?
Yes, so, but nowadays we have not so many satellites and we have not many capability. So today we deliver the data limited partner. So we deliver the limited partner to our data and collaborating and making algorithm or making application. But if you are interested in our company or our partner, please contact me. We are very, very happy to collaborate with you. Thank you very much.
Are there any more questions? Okay, well, let's thank Vero one more time.
Thank you very much.